So in yesterday's class, we discussed the concept of normal forms and how we process it to move from one normal form to another normal form. So with a view of redundancy and anomalies in mind, those tests on relations are applied in order to refine the database. So then we discussed the concept of super key and key with an example in an very elaborated way. So in order to identify the differences between a super key and key. So the table that we uh, took was USN, then followed by name, mobile and semester. Then we identified which are the possible super keys, that is a sets. And once we filtered the super keys, then for on the super keys, so we will apply the key. So key is a super key with an additional property that removal of any one attribute from super key will no longer remain a super key anymore. So when we applied a key, means the rules by observing if we remove one attribute, will it still remain a key or not? Then we are left with only two sets, that is USN and mobile. So that is a two sets were available for us. So for this particular table containing four attributes, so these four attributes, so our key is these two. So this table is having two keys, USN and mobile number. Once we identify a key, then we will identify the candidate keys. So the next set of definition, if a relational schema has more than one key, then each key is called as a candidate key. So in our previous case, did we have a more than one key? Yes, we had two keys. So one is a set, one set of key, it is USN. So another set, it is the mobile number. So now, if any relation is having more than one key, then each of them is called a candidate key. So which means USN is one candidate key and mobile number is another candidate keys. So two candidate keys are there. Now, a prime attribute must be a member of some candidate key. So when we have two candidates like this, we will arbitrarily choose. Arbitrarily means it is depending on the application and the database designer who thinks which has to be designated. So we can arbitrarily select one candidate key and designate it as primary key, right? So in our example, for that particular table, we have two candidate keys, USN and mobile number. Out of these two attributes, we can select one candidate key and we can designate and call it as primary key. So which means in that table, we can choose USN as a primary key or mobile as a primary key. So that is our wish. So normally what we do, we will use USN because it is a USN that we will use in many places in our table design. Again, it is a wish of a designer. We can also use mobile number, so it doesn't matter. But does all the student have a mobile number? That is a question. But every student will have a USN. So arbitrarily we'll choose USN as a primary key. So this is the difference between a super key, then key, candidate key and primary key. So whatever primary key we have selected, it is also a candidate key because primary key is selected from candidate key. So if we represent everything, then at the core of it, it remains the first thing it remains is the super key. So super key is the core part. Okay. Then within the super key, we'll have a key. Okay. Then if there are two keys, then we'll have candidate key. Then we'll have primary key. So if we represent it as a one big circle, so then key like this, then candidate key and primary key another like this, and primary key is another like this. So the outer one is the uh, super key, the outer one is the super key, then the inner one is a key, then we have a candidate key, and inside it is a primary key. So this is the definitions. So when we first hear all the terms, it looks same and similar, but this is the difference between these four terms. If we understand, if you understand the difference between these four terms, then I say 50% of dbms concepts is clear. If you know how to select a super key and a key, candidate key, and how to designate a primary key on a relation, then designing of database is done. Next, only thing, the rest of the 50% remains is the normalization process and writing the query on the other part, that is the other side of database. So 50% of design of the database. So when I say 50%, it is a design. Another 50% is the normalization. So once these two concepts are clear, then querying, putting a query on a database is another part in the database design. So with the knowledge of these four terms, so we will now move on to first normal form. So the first normal form is considered to be a part of formal definition of a relation. So it is defined to disallow multi-valued attributes and composite attributes or their combination. So which means whenever we decide any attribute, that attribute has to be atomic. So atomic means it cannot be further divided. So we'll design or select our attributes such that it is atomic. Atomic means no further division possible. So when we select the attributes for our table, simply ignore composite attributes and multi-valued attributes. That's it. It becomes first normal form. If we don't have a composite attribute and if we don't have a multi-valued attributes, then we will say that the relation or the table is obeying the rules of first normal form. So what are composite attributes? Composite attribute means an attribute that can be further divided. For example, address field. Address field can be further divided into city, state, then country, like that. If we are putting all the parts in a single attribute, then it becomes a composite attribute. If we divide it into different attributes, then it is fine. But together it is not allowed. So that is a composite attribute. So multi-valued attribute means An attribute, it is capable of taking multiple values. For example, degree of a person. So degree of a person means one person can have any number of degrees, MSc, ME, BE, so an MBA, like that. Multiple degrees are possible, which means it become a multi-valued attribute. So that is disallowed. So an attribute cannot take multiple values. So if we avoid these two, then our table is said to be in first normal form. So let us consider an example from the company database for this. So look at this. So a department table is having department name, department number, department manager SSN, and the department location. And when we first discussed the company database, we discussed that one department can spread across multiple locations. So same department can present in multiple locations. So that we had discussed. So if we had used this table, then our data would look like this. Research department, department number 5, this is the manager, and it is present in 3 locations. So this, when we have 3 values, this is the multi-valued. So this become multi-valued. So according to the definition of first normal form, multi-valued is disallowed. Even though we want the department to be in multiple locations, so this cannot be stored in a single table. So what is the solution for it? So the solution is, you can store like this 3 times. So if you observe here, 3 times it is repeated, and each time the location is different. But again, if we store like this, we have to designate 2 attributes as a prime. So which means our primary key will now be combination of 2 things. So department number and department location. But again, it is allowed. So if you want to pass through the first normal form, this is what we can just do. Same number of attributes, but now in this case only one primary key. Now we have designated 2 as the primary, which means the combination of department number and D location will be primary key now. So this particular set, because multi-valued is not allowed. So this table is set to be in 1NF. So another example, we will look into it. Yeah, this is the employee and project relation. Okay, so you can look at here, employee project. So SSN is also there, employee name is there, project number and number of hours the employee is working. All the things are put together in a single table, which means 4 attributes are there in a single table. So now what happens if, now look at the data. This employee, his name, he is working on 2 projects. So project number 1, project number 2, on 1 32 hours, on 2 7.7 hours. So similarly, this employee is working on 2 projects, this employee is working on 4 projects, he is working on 2, here also 2, and he is not working on any project. So now again, project number 1 and 2, how we can store it in a table. So 2 values. So when we have this kind of data, we can divide the table such that here there is a division. So SSN and E name into one table, then SSN, project number and hours in the another table. So a single table is now split. So it is split into two tables, SSN, employee name, SSN, project number and hours. Now you may ask, SSN is present two times. Is it not redundancy? Yes, it is redundancy, but it is necessary for us. If SSN is not present in both the tables, then how will we join the data back? If SSN is not repeated, then there is no means of joining the two. So whatever primary key we have, that has to be repeated. We cannot repeat name because same name multiple employees can have, but it is the SSN that no two employees will have a same value. So it is the SSN based on which the two tables will be joined. So this is the process. This table undergoes the 1NF normalization process and result is this one. So one table is split into or decomposed into two tables, and still the functional dependency is retained. Still ename depends on SSN and the hours depends on SSN and the project number. So that is a functional dependency. So this process is 1NF. So to summarize, in first normal form, there should not be multi-valued attributes and composite attributes. If any composite attributes are there, we will create the columns for each part. For example, in an address field, so address will have the city, district, state, country, right? So these are all the parts. For each part, instead of combining all the four into a single attribute, we can now divide it into four attributes. Now when we divide it into four attributes, then the compositeness is lost. It will not cause any problem for us. So it is still in normal form. So if we have composite attributes, then we can divide it, right? Then if we have multi-valued attributes like this, where two things are there. In our previous example, only department location was there. But here, two things are repeating, project number and hours. So when we have like this, we can divide the table into two parts. On the one part, SSN is the primary key. On the another part, SSN and project number is the primary key. But in the previous example, so if we go back in this table, so we have made department number and department location both as part of primary key. So that we were able to do it because only one attribute was such that it has a multiple value. But in the next case, it is not so because here two attributes are there. So if more than one is there, then we have to divide it to bring it into first normal form. So with this, we will now move on to the second normal form. So the second normal form will use the concept of functional dependency and primary key, whereas the first normal form we never use the functional dependency and primary key. We just observed the multi-valued and composite, divided it based on that, and primary key we saw to some extent so that joining of two decomposed tables can take place. So in the second normal form, we will use the term full functional dependency. So a prime attribute is an attribute that is member of a primary key. Full functional dependency. So a functional dependency is said to be full when removal of any attribute from Y, which means functional dependency doesn't hold anymore. So look at the examples. Let us discuss few functional dependencies. So this is one functional dependency, that is SSN and project number determining hours is a full functional dependency, since we cannot determine hours just based on SSN, because one employee can work on many projects. So how can we say hours is dependent just on SSN? So hours is dependent not just on SSN but also on a project number. So both should be there. So this functional dependency doesn't hold. Similarly, project number cannot alone decide the hours, because SSN is also there, because many employees may be working on the same project. So we can't say hour value just based on a project number. So in order to say what is the hour value, we need both SSN and project number. So we cannot decompose it. So when we have such kind of functional dependencies where we cannot further divide it or remove any attribute from left side of the functional dependency, so in these cases, we say if removing any attribute makes it uh, removes the functional dependency and it doesn't hold, then we say this hover is fully dependent on this. So in this case, we say it is fully functionally dependent. So when do we say the functional dependency is full? So a functional dependency is called as fully functionally dependent if removal of any attribute from the left part of the functional dependency, then the dependency doesn't hold anymore. So if a functional dependency is like this, y and z, if I remove one attribute from y and still the functional dependency hold, then it is not called as fully functional dependency. If I remove any one attribute from y, then the functional dependency doesn't hold, then that is called as fully functionally dependent. Now consider one more example. SSN, project number, employee name. So does employee name depend on SSN? The answer is yes. So SSN determines employee name because name depends on SSN, right? So if we remove project number, still the dependency is valid because employee name is still determined by SSN. Now, if we remove SSN from this, will this dependency hold? Pay number to e name, will it hold? No, because employee name doesn't depend on project number. If I give a project number, can we say employee name? So that is not possible because many employees will be working on a same project. So this dependency doesn't hold. When this type of dependency doesn't hold, then we say this whatever functional dependency we have here, it is not full. Instead, we say it is partial because it is partially dependent on the part of the attributes. So in order to understand the second normal form, we must understand the concept of fully functionally dependent. So now we'll come to the definition of second normal form. So that is a relational schema R is said to be in second normal form if every non-prime attribute is fully functionally dependent on a primary key R. If 2NF is violated, then what we'll do? We'll just divide the table. So let us again consider the same example. So all non-attributes should functionally depend on primary key. So what is the meaning of it? So if we have USN, name, mobile, and then semester. So which are the non-prime attributes? Name and semester. So the meaning of 2NF is the non-prime attributes should depend on prime attributes. That's the meaning. So semester should also depend on USN. Anyway, they also depend on mobile number, right? So consider this example where we will normalize the table into 2NF and 3NF. So first we'll see how it is normalized into 2NF. So because we have not discussed 3NF yet. So first part we will see till here. So what are the things we have? SSN, project number, hours, employee name, project name, and location. So all the things are there in the same table. So what is the functional dependency that exists over here? So what is the functional dependency? So this is just an example we have taken. So suppose we have such table in the employee company database: SSN, project number, hours, employee name, project name, location. So we have identified SSN and project number both together to be a primary key. Now hours. So on what hours depend? So hours depend on both um, SSN and SSN and project number is determining hours. So that is the first functional dependency, right? Then employee name. So employee name is depending on what? So employee name is depending on SSN. So it doesn't depend on project name. So employee name and project name. So next attribute, non-prime attribute is a project name. So project name depends on project number. So project number will determine the project name and project location. So again, project location is dependent on project number only. It doesn't depend on SSN. Now, if we had used SSN and project number both as a primary key, then you can observe employee name is dependent only on a part of a primary key. So which means it is not fully dependent on a primary key. It is dependent on a part of a primary key. So when we have this kind of functional dependency, what we'll do is we'll divide the table. So look at here. First functional dependency, SSN project number. For this, one table is created here. So the division is taking place. So where we'll have SSN, project number, and hours. One. Second part, SSN and employee name. So employee name is dependent only on part. Which part? SSN. So that functional dependency will create one more table for this particular functional dependency. Next, another project name. It is dependent on project number. It is not dependent on SSN. So we'll again divide it. And again, location. It is dependent on again project number. So two things are dependent on project number. So these. So for these two, okay. So it is dependent on project number. So both are dependent on project number only. So these two can be put in a single table. So for this one, it is another table. So this one. So three categories are there. One non-prime attribute hovers, it is depending on both. Then another non-prime attribute name, that is depending on SSN. Another non-prime attribute project name, it is depending on project number, and project location, it is depending on project number. So all three combinations are there, one on both, another on single attribute. So all the things are put together. So now when we apply the process of second normal form, this single table is divided into three tables. So that is depending on which attribute they are depending. So this decomposition is a process of 2NF. So that is second normal form. So to put it in simple terms, in second normal form, we expect that in the table all non-prime attributes, non-prime means except those which we have designated as a primary key, so all of them have to depend completely on the primary key. It cannot depend on one attribute of a primary key or two attributes of a primary key and leaving others not dependent on other attributes. So which means here in employee name, if it has to satisfy a second normal form, it has to depend on both SSN and project number. But in this case, it is not so. It is not depending on both. It is depending on only one. So if it is depending on only one and not on the other, then it is violating the second normal form. If it is violating the second normal form, then we'll decompose the table. So the whole intention of second normal form is to make a non-prime attribute to depend completely on a primary key. So primary key can have any number of attributes. If it is having 10 attributes, then a non-prime attribute should depend on all the 10. If it is depending on 9 and leaving out 1, then we will decompose the table. So all 9 attributes on one side along with the 9 the non-prime attribute are into another table. So that is how the 2NF expects a table to be fully functionally dependent on the primary key. So here the second normal form, it is based on a primary key of a table. If a table is having only one attribute as a primary key, then it is already in the second normal form. So need for applying the second normal form arises only when a table is having more than one attribute as a primary key. Because if we have only one attribute as a primary key, then all of them will depend on it, fully functionally dependent. So it obviously became 2NF and we need not process it, we'll just move on to the third normal form. So this is about the second normal form. So in our we can stop till here. We'll discuss the third normal form in our next class. So you can enter your attendance and leave.